All right, get ready to have your minds blown wide open because we're diving headfirst into the most mysterious objects in the universe, black holes.
And we've got some seriously juicy source material to work with.
Yeah, we do.
Yeah.
We're talking about those theories that really stretch what we think we know about these cosmic enigmas.
Absolutely. Like, are we really talking about portals to other universes?
I mean, could they really be?
And what about those walls of intense energy just waiting to incinerate anything that gets too close?
Oh, and don't even get me started on the whole black holes as time machines thing.
Oh, we're going there.
Oh, we're definitely going there.
Okay, then let's do it.
So let's kick things off with this idea of black holes as portals. It's like a classic in science fiction, right?
Yeah, it's like a staple.
Fall into a black hole, boom, you pop out in some completely different universe.
Right, like you just hop through a door.
Pretty wild, right?
Yeah, it's definitely a cool thought. I mean, who wouldn't want to hop between universes? The reality, though, is that the gravity inside a black hole...
Yeah, the gravity is insane.
Insane. It's so strong that anything falling in would basically be stretched and squished like, well...
Like what?
Like cosmic spaghetti.
Cosmic spaghetti. Oh, that is not appealing. So much for leisurely trips through the cosmos, then.
Right. No scenic routes through black holes.
But there are, other theories, right?
Oh, yeah, definitely.
About traveling between universes.
Totally. And this is where it gets even more interesting. So while the idea of a black hole being like a doorway might not hold up, there's this concept of wormholes.
Wormholes, okay.
Yeah, so imagine wormholes as these theoretical tunnels connecting different points in space and time, right?
Okay, I'm picturing it. Like a shortcut through the universe.
Exactly. It would be like folding a piece of paper in half and poking a hole through it. So instead of traveling the long way around, you take this shortcut through the wormhole.
Ah, that makes sense.
And who knows, maybe those shortcuts lead to entirely different universes.
Now that is mind-boggling. And wait, wasn't there something about our universe actually being inside a black hole?
Oh yeah, you're talking about black hole cosmology. That one's a real head-scratcher.
So explain this to me, because my brain is already starting to hurt.
Basically, it suggests that everything we know, everything we see, our entire universe, it's all contained within the singularity of a supermassive black hole.
Hold on, so there's a black hole in some other universe. And inside that black hole is our universe.
Precisely. I know, it's almost impossible to visualize.
It's like a cosmic Russian nesting doll situation.
Oh, yeah, something like that. And while it's not the most widely accepted theory out there...
Yeah, I can see why.
It definitely makes you question everything you thought you knew about, well, reality itself.
Okay, let's switch gears here. We've got to talk about firewalls, because this is some seriously intense stuff.
Oh yeah, firewalls are where it gets really heated.
So we're talking about a wall of pure energy, right, surrounding a black hole, ready to obliterate anything that dares to cross its path.
It's not a very welcoming place, that's for sure.
Yeah.
And this is where the paradox comes in.
Okay, because firewalls seem to go against what we thought we knew about black holes.
Right. Exactly. You see, there's this principle called the no-hair theorem.
No-hair theorem, like black holes are bald or something.
Well, not exactly. It means that black holes, they really only care about a few things: mass, charge, and spin.
So what falls into them doesn't really matter.
Right. The information about what falls in is thought to be lost. But then quantum mechanics comes along and throws a wrench in things.
Always complicating things, that quantum mechanics.
Because it suggests that information can't be destroyed. So if something falls into a black hole, the information about it should still be preserved somewhere.
So we've got general relativity saying one thing and quantum mechanics saying another. That's where the firewall idea comes in.
Exactly. It's like these two major pillars of physics are butting heads right at the edge of a black hole.
So firewalls are like a way to try and reconcile these two conflicting ideas.
In a way, yes, but it's a very controversial concept, and physicists are still trying to figure out if firewalls actually exist or if we need a completely new understanding of how gravity works at the quantum level.
Well, it's definitely a mind-blowing concept.
It is.
Okay, ready to dive into the most mind-bending concept of them all.
Bring it on! I think we're ready.
Black holes as time machines. Is this really a possibility?
Well, first, we have to remember that time is not a constant, it's relative.
Okay, remind me what that means.
So imagine you're watching a clock falling into a black hole.
Okay, I'm picturing it. A very unfortunate clock.
From your perspective, standing safely outside the black hole, the clock's hands would appear to slow down as it gets closer and closer to the event horizon.
The event horizon, that's the point of no return, right?
Exactly. And as the clock approaches the event horizon, it would eventually seem to stop altogether.
Like a cosmic freeze frame.
Kind of. This is because of time dilation. The immense gravity of the black hole warps time.
But wouldn't the person falling in with the clock still experience time normally?
Yes, for them, time would continue to flow at its usual pace.
So time is literally different depending on where you are in relation to the black hole.
Exactly. It's wild, isn't it?
It really is. But hold on, if falling into a black hole doesn't really allow for time travel, what about those other theoretical methods we hear about?
Ah, yes. So remember those wormholes we were talking about?
The shortcuts through space and time.
Well, some theories suggest that if we could create or manipulate wormholes, we might be able to use them for time travel.
Okay, that sounds a lot more like the time travel we see in movies.
Right. And then there are these other crazy ideas like cosmic strings, which are like defects in the fabric of space-time itself. Some physicists believe manipulating these cosmic strings could also lead to time travel.
Okay, I'm trying to wrap my head around cosmic strings. And there's something called an Alcubierre drive too, right?
You got it. The Alcubierre drive is a theoretical concept that involves warping space-time in a way that would allow a spacecraft to travel faster than light. And because of the whole relativity thing, traveling faster than light could potentially allow for time travel as well.
Wow, okay. So many mind-blowing possibilities. It's amazing, isn't it? How these theories about black holes force us to question everything we thought we knew about space, time, and the universe itself.
They really do, and we've only just scratched the surface.
Yeah, I mean, black holes are still some of the most mysterious and enigmatic objects out there.
Absolutely.
So we've explored some truly wild concepts today. Portals to other universes, fiery walls of destruction, time travel. It's enough to make your head spin.
But it's that sense of wonder and mystery that keeps us exploring, right?
Absolutely. So here's a question to ponder as we wrap things up. If you could actually travel through time, knowing what we've discussed about the immense gravity and those potential dangers lurking near black holes, would you risk a trip through a wormhole or stick to exploring the universe from the safety of our own planet?
It's a tough choice, but I think I'd play it safe. I'm pretty attached to this planet.
Yeah, Earth is pretty great,
Yeah.
but the cosmos is calling. Maybe someday, who knows? Thanks for taking this deep dive with us, everyone. Until next time.